Hello everyone. In this video, we are going to explore Istio, one of the most popular service meshes for Kubernetes. We will start with what Istio is, why we need Istio in a Kubernetes environment, and then I'll walk you through a high-level architecture diagram before jumping into the hands-on demo. So Istio is an open source service mesh built on Envoy proxy. So for those who don't know what service mesh is, it is a dedicated infrastructure layer for managing, observing, and securing service-to-service communication in a microservice-based application system. So Istio adds traffic control, observability, security, all these without requiring any changes to the application code. So why do we need Istio? So as we all know, Kubernetes alone gives us service discovery and DNS, the basic load balancing, ingress for external traffic. But Kubernetes does not provide version-aware routing. Kubernetes service sends traffic randomly to any pod. You cannot say that send 10% traffic to version V1 and send remaining 90% to version V2, or route user X or Y to a specific version only. The next thing is encryption, especially the mutual TLS. By default, service-to-service traffic in Kubernetes is plain text. So there is no built-in encryption or strong identity. Another thing is service-to-service call visibility. It is very hard to answer which service called which, how often, what is the latency or error occurred. So Kubernetes does not give request level tracing or metrics out of the box. So that's why Istio adds on top traffic management, security, and observability. Istio helps in getting fine-grained version-aware routing, retries, timeout, fault injections, and in terms of security, it helps in enabling mutual TLS between services, policy-based access control, and coming to observability, it helps in getting detailed telemetry, metrics, traces, logs, create service graph using tools like Kiali, all this with zero code changes in our application. So in short, Kubernetes gets services talking, but Istio makes that communication smarter, safer, and more visible. Moving on, in this video, we will be deploying a sample application on Kubernetes, expose it via NGINX Ingress, then add Istio as a service mesh, and finally control traffic with virtual services. And then we will be also enabling mutual TLS for security. This is the high-level architecture without Istio installed. So here the Bookinfo application running on Kubernetes, the product page service called reviews, details, and ratings. Kubernetes take care of basic load balancing. So requests can hit V1, V2, or V3, but there is no version aware routing, no encryption between services. So which service is calling which we will be not able to understand. And everything is just plain HTTP traffic. Now, this is the high-level diagram with Istio installed. So when Istio is added, every service has an Envoy sidecar proxy injected. All communication between service flows through this sidecars, which is represented here in brown. That means Istio can enforce encryption with mutual TLS, control traffic intelligently. For example, send only 20% traffic to version V3 of reviews and generate detailed telemetry about every call. We can also use Istio as Ingress gateway, but in our case, we are trying to use NGINX Ingress, which is already in place, but we can replace it with Istio Ingress. So instead of basic networking, we now get secure and observable networking. Now let's start with the demo. For that, I have opened the README for this demo. We need Docker desktop with Kubernetes enabled and kubectl and Helm installed for this lab. To start with, we will be deploying the Bookinfo application in a namespace Bookinfo. So let's copy this, created the namespace. We'll be using this YAML file for deploying the application. Let me show you the YAML. This is a Kubernetes manifest, which will be having the service deployment. You see the deployment here for details. We have version 1. And if I scroll down for the ratings, we have version 1. But for reviews, you can see version 1 is there, then V2 is there. Okay, so let's quickly deploy it and investigate more on this. To a kubectl apply. Yeah, kubectl get pods and looking for. Yeah, so we have the pods created. There is one pod for details microservice, one for product page, one for ratings. And if you see the reviews, there are 3 different versions, V1, V2, V3. Right. Now let's continue creating an Ingress YAML. So in this cluster, I have already installed Ingress Controller, which is covered in the previous tutorial. So if I do kubectl get pods minus and Ingress NGINX, yeah, you can see the Ingress control running here. So now it's just a matter of creating the Ingress file. I have the Ingress file already copied in my local machine. Let me open it in a text editor. Ingress YAML. It is just a straightforward Ingress file with all the parts for product. This is static path. This is a login page, a logout page, and to list the products. So to deploy it, let me just quickly do kubectl apply minus f. Yes, right. If I do kubectl get ing minus and Bookinfo, you can see the Ingress. So I have created a host bookinfo.local and I have updated the etc host file. You can see it here. So that's the local host. Now let's try accessing this application in the web browser. It is bookinfo.local. Okay, the actual path is product page. To get more information on this application, if you go to the Istio documentation, yeah, right. So I have used this Bookinfo application, which Istio has provided as in the documentation. So here, the product page microservice calls the details and reviews microservice to populate the page. The detailed microservice contains book information. And if you see the reviews here, the reviews microservice contains book reviews. Okay. There are 3 versions of reviews microservice. So version V1, V2, and V3. So V1 doesn't call the rating service. V2 calls rating service and displays each rating as 1 to 5 black stars. And finally, version 3 will be having 1 to 5 red stars. So let's try refreshing. So if you see now, it is uh, reviews version V3 where we have the red star. And if I refresh the page, I can see it's a black star and it is coming from reviews version V2. Let me do a refresh again. It's again from V3. This is from V2. Now, if you see there are no stars, that means it is coming from version V1. So version V1 doesn't call the rating service. That's why we are not able to see any rating stars here. By this, what we understand is whenever the request comes in, the Kubernetes service will route traffic to underlying pods randomly. That's why we are seeing multiple outputs, which is received from different versions of review microservice. Now it's time to introduce Istio. So let me go back to the README and start deploying Istio. For this, we will be using Helm chart. We will be adding the Helm repo for Istio, then do a Helm repo update, create a namespace for Istio, and then do installation of Istio base and Istio-D, which is the control plane for Istio. Let me copy this. Yeah, so that's added now. Create the namespace Istio system. We'll install the CRDs for Istio base. Okay, now let's install Istio-D. So that's done. Let me just quickly do kubectl and get ports minus an Istio system. Now we have to inject the envoy sidecar to the ports of the application. So for that, we have to label the namespace. So in our case, if I do kubectl and get ports minus n Bookinfo. These are the ports of the microservices or the Bookinfo applications which we have deployed. And we can see here there's only one container running here. So now what we will do is we will inject the sidecar to all these ports. For that, we will be labeling this specific namespace so that any ports deployed in this namespace will have a Istio sidecar. Okay, so I can just do kubectl label the namespace. And if you see the label is Istio injection is enabled. So yeah, so that's now done. If I do get ports again, so still you can see one by one. So to get this affected, we need to restart all the ports. So yeah, let me restart it. Okay. Yeah, so all the microservice ports has been restarted. Now if I do get ports again, so we can see two containers for each of the ports. Yeah, okay. Let me do a describe on one of the pods. And if you check the container, so there are two containers. One is details for this specific pod, another is Istio proxy. Here you go, and this is the proxy version. Next, we need to create the destination rule for Istio. So right now, Kubernetes only knows that we have a service called reviews. It doesn't care that there are three versions, which is V1, V2, V3 in our case. So a destination rule in Istio tells the service mesh about these subsets. So we say that reviews has a V1 subset, a V2 subset, and a V3 subset based on their labels. Okay, let me open the destination rule file for you. Yeah. So if you see here, we have the destination rules for each microservice. The product, I'll more concentrate on the reviews one. In the reviews destination rule, you can see subsets V1, V2, and V3. Similarly, for ratings also, we have a couple of different subsets. So now let's create the destination rule for the specific application. It will apply. Okay, so we have created 4 destination rules for each of the microservices, product reviews, ratings, details. Yeah, so that's now created. Next, we will be looking into creating virtual service. So once the destination rule is created, that is the subset is in place, we need to decide how to send traffic to them. So that's the job of a virtual service. So with a virtual service, we can say that send 100% of the incoming traffic to a specific version, maybe V3 or V1. Or we can say split 80% to V1 and 20% to V3. Or we can say that route only a specific user to version V3. So those kind of traffic routes or rules can be set using virtual services. So I have created separate virtual service files here. So if you say this one, VS complete traffic to one single version. Here in this virtual service, it clearly says that the route should be subset 3. The version 3, sorry, not 3, V3. The host is reviewing. So if I create this virtual service, any calls coming incoming to the service will be routed to version 3 of subset. So let's quickly try creating this virtual service. So for that, kubectl apply sf virtual service complete traffic to, yeah. That's now created. And let's go back to the application. Let me refresh this page. Okay, so if you see here, we are getting the response from reviews version v3. Let me keep on refreshing. So it's not changing at all. Now, let's go back to the virtual service again. So as it says, the destination subset is version 3 of a reviews microservice. So because of this, every call will be going to version 3. Now let's try a different one. Traffic splitting. So here in this virtual service file, you can see that there are 2 destinations. One is reviews version 1 and the other one is version 3. So version 1 is of weight 80 and version 3 of 20. That means 80% of traffic will be routed to version 1 and remaining 20 to version 3. Okay, now let's go back to the command line and we will create the new virtual service. Okay, before that, let me delete the existing one. So we will be using VS traffic splitting YAML file. So it's create, let's verify it. Yeah, so we have the virtual service created. Now I'll go back to the application UI. Let's start with a refresh. So now the response is served by V1. Second time it's V3. third time again V1, 4 V1. Yeah. So I had given a couple of requests to this. So basically 80% of traffic will be routed to version V1 and 20% is to V3. So that's this traffic splitting mechanism. Now let's try a user-based YAML. So let me quickly delete the one which we created now. Okay. So in the user-based one, if you see here, we have a header match option on the host. So the host is reviews. We have the route here, two routes here. One is to subset V2 and other one is subset V1. In the header, the end user, okay, I'll give my name here. The username is Praveen. So if the if the header is having username Praveen, the traffic will be routed to version V2 and the rest of the request will be routed to version V1. So for that, let me go back to the UI and create the user. So this application is having a sign-in option. Here, I'll just type my name and a password. Sign in and I'm signed in. Now, if you see, since I am accessing the application as a username Praveen, the response will be coming from reviews subset V2. But on the same side, if I log out and then do it, so the response is coming from version V1. So that is what virtual service also says. If the header is having a username which matches Praveen, the traffic will be routed to subset V2. In other cases, it will be routed to version V1. Right. Now, let's try another virtual service which we have created for checking fault injection. So this virtual service used for fault injection will be having a 5 second of delay, which is applicable for every request. That's why the percentage value is 100 here. And it will be routed to subset V2. So in real world, this is very much helpful for chaos engineering. So where we need to simulate latency in a downstream system, like the reviews one which we are seeing now, and test if the calling service can handle slow responses. So for this kind of thing, we can make use of Istio. And then, of course, in case of SLA and SLO testing, if your service level objective is 95% of request under 2 seconds, you can inject delays to see if monitoring alerts fire as expected. Then we can configure retry strategy based on this. So in short, the virtual service doesn't change the app at all. Instead, Istio intercepts the traffic and deliberately do the changes required. For example, in this case, it injects a 5 second delay. Yeah. So we can create all these virtual service using a single YAML file. So I have a file called VS all-in-one YAML here, which has different routes. And so, for example, if you see the first one, destination is V3, where it is trying to match the username. Then the second case, sorry, the second case is version V2, and the first is just V3. The third case, it is trying to match the user name tester, where it is actually giving a delay of 5 seconds to all the traffic coming into this pod. Similarly, we have another one which is splitting the traffic 50-50, 50 percentage to version V1 and 50 to version V3. So this is an example of virtual service with all these together in a single file. So that's it for now. Thanks for watching. And if you find this useful, please do share with your friends. See you in the next one.